Okay guys, welcome back to the channel. No hat today. Going with my Kramer look. It's late at night. Didn't even want to put on a hat. So rare chance to see me without a hat on. But I got a cool video for you today. It almost looks like I put my finger in the light socket. Well, the topic of today is power chords. And coincidentally, it's going to be applicable what I just said, because the common thing when you talk about power chords, it's a very controversial topic, and I want to tell you first, before we get to this Zoom that I had with Jeff of Blue Jeans Cable, and we go into some specifics with their new power cord. Now, if you remember, I had the Zoom with Jeff of Blue Jeans Cable that they introduced their Octaquad, that they're only selling through dealers, and I'm one of the dealers for that. Already sold several of those. But they also mentioned in that Zoom they're doing a power cord for the first time. And he mentioned they were only going to do a power cord if they could create something that superseded what was out there, even regardless of cost, on the metrics that they value. And what we're going to talk about today is, do power cords make a difference? Well, actually they do in quite a few areas that people don't focus on. So that's what we're going to talk about today, and Jeff's going to go into a lot more detail. But I wanted to, before we even get to that, kind of highlight and summarize for you some of those things, but also my background with power chords to supplement what we're going to be talking about. Because for most of the hobby, I just ignore power chords. I just use the normal one that comes with the gear. And I was against using upgraded power chords because they just didn't pass the smell test with me and my intuition. And then I'd go to these demos at shows where mega dollar power chords, and they do an A/B test in the room. And I didn't hear any difference. And they were saying, oh, it's at least a dB or two louder when we went to this model. And I'm like, okay. So I asked the question. They don't usually like questions. And you can see why, because when I asked, I said, well, if you know it goes a dB or two higher with that power cord, do you have the measurements proving that? I mean, obviously, you just can't say it goes up a dB without measuring that. Well, of course, they didn't have the measurements. And they said they'd get back to me and never got back with me. So I was always against power chords in terms of all the audiophile jargon and the huge delta and amazing differences that they make. I just never believed that that was as real as people made it out to be, or as big a deal to focus on. However, when I went to inacoustic, and then even before that, I started trying some of these chords myself. I even had a $2,000 power cord, fancy ribbon, cable, fancy jacketing, yada, 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 one of the best supposedly in the world. So on top of all the ones I've seen at dealers, demos, then having myself, my friend Doug got them. We gave these cords that we got, high dollar ones, to other people to test. And again, the delta in what people heard was not that great to justify the cost. But what we did find out is some of these cords that are exotic aren't even that great in terms of metrics that are even more important. And that's what you're going to hear about today. Don't want to spoil it, but two things that I think power chords do make a difference, and what you should elevate as the highest priority when you're looking at what cable to buy is safety and also the RF field that emanates from them. If you recall, I did a video recently about cable elevators. And sure enough, Jeff told me, we were talking, he's like, I really liked your video on cable elevators. And I was like, wow, Blue Jeans Cable likes cable elevators? I would think that they would think that's BS. But he said, no, you actually broke it down to where it can matter, especially when you're having power cables run next to signal cables. And the RF field that emanates from those power cables is something on top of the construction quality and the connectors you're going to hear about. You want to watch that. Really important. Don't overlook safety and reliability. But the other thing that I was really amazed at as well is that they paid a lot of attention to that RF field that's emanating from the power cord. You don't really need to worry about, as he talks about in more detail, what gets into the cord, and he'll explain why, but what comes off of the cord, and how the FCC even regulates some of these things, and how they have actually spent time studying the insulation inside the cord to reduce that, and found the right insulation to reduce the amount of RF leaving the cord. So again, I don't want to spoil it. He's going to go into a lot more detail for you. But these are two things right off the bat where you benchmark this cable by Blue Jeans against some other ones, regardless of cost, they're going to beat you. They're going to be superior. So it's, again, it's about being a high IQ audiophile that can find the real improvements and not just look at cost and assume it's better. That's what I learned the hard way with power cords that I've tried, and hopefully I can avoid that happening to you. I do also represent the Blue Jeans cable, and I'm proud too. After I heard all these things that they prioritize, it's exact same things that I saw, and why I liked In Acoustic as well, what they did in the same vein. This is the kind of things you want to look for, guys. So enjoy this Zoom, and I'll see you back here soon. There's going to be a lot more parts to the Zoom, actually. This is just part one. It was over an hour, so there's other things about the cord, but stay tuned for that in a future episode.
So one of the things I wanted to cover with you today is kind of addressing the fact that the perception of Blue Jeans cable is Blue Jeans, as you talked about, the name you all picked was more for practical, reasonable, and all those objective and scientific measurements that I think are very important and has resonated for decades with you guys and your customer base. But I think what gets lost in under the Blue Jeans and the pricing is that people think they're sacrificing some level of performance, when it's quite the opposite in reality, based on what you've come out now with the Octaquad. I mean, I would put those speaker cables up against anything in the hobby. Within reason, it's probably superior to many on any objective metric that you want to measure. And then subjective, that's always going to be debatable, and aesthetics. But yeah, I would put that up against anything regardless of price. But I actually wanted to learn more about, I touched on it at the last Zoom, your power cables, because one of my members already bought the power cables and liked them so much, he ordered more, which is as good a testimonial as it gets, and he may join the Zoom, but wanted to get from you a little bit more of the details, like we talked about Octaquad, what went into Blue Jeans finally doing a power cable, anything geometry, connectors, conductors. And I know we talked on the phone briefly, just anecdotally, about shielding versus no shielding, and I was very intrigued. I thought I had heard it all in terms of what people did to research power cords and all this in this area, and I thought I knew, but yeah, you impressed me with what y'all have done in that realm. So kind of wanted to turn it over to you and walk us through the power cord thought process and how that came about.
Sure. We've always been very agnostic when it came to power cables. But there's always been people asked us for years and years, when are you going to make a power cable? When are you going to make a power cable? And so I started to look into this a few years back. And one of my concerns about getting into power cables, honestly, was safety issues. Like when you're building power cables, now you're building a product that, if it was built inadequately, could blow up somebody's amp, could burn somebody's house down. I mean, this is serious stuff. This isn't like, an interconnect or speaker cable where the worst thing that's going to happen is it's just not going to sound very good. So I really wanted to make sure that if we were going to do it, that we could do it in a way that everybody here felt 100% good about every single thing that went out. So there was a couple things that went into that. The connector design is number one. So I can tell you, I don't want to name names, but I've looked at a lot of boutique power cables. I've had stuff sent in here, both market stuff and even like prototype stuff. There's some crazy stuff out there. And no matter what else you want to say about it, a lot of it, frankly, is kind of delicate, because you get into these really, really heavy gauges. Now, how that cable is interfacing with the connector, both at the strain relief and then the actual pins, this becomes real critical, right? So we can't have a fully metal connector body, right? Because there's just too much potential for bridging. So you have to use some plastic in there. So how that strain is now going to get in there is really, that's what scares me. Because obviously, if you build your own boutique power cable and you use 3 zero gauge wires and have a connector that's big around on the back, yeah, you can do that. But because you built it, you're going to know that you need to gingerly handle this thing when you're connecting it and disconnecting it. But if you create a product and then you're selling that to whoever, they're not, you have no way of knowing whether that person is going to just chunk it in there and let his dog run into it or whatever. And so now it's a completely different set of problems. So, we wanted to make sure that, these connectors were going to be on here solid. So one thing is 360-degree of strain relief. So when this screws down, all of these little pins here are squeezing up against the jacket. So this is going to make sure that every single bend is going against this ring back here. It's not going into the pin body. And then it's how the pins interface inside. They need to be a full double clamp, right? So basically 2 sides need to come together and squish each of the 3 conductors, not a set screw that pushes down one way, because now you've got this asymmetry. You need to squish down equally pressure on both sides. That's important. And then you need some kind of like hard insulated plastic that is not going to take any strain or be able to break, that covers all of that metal part on the inside so that there's no chance of bridging. So that's one. And then I wanted to make sure that I could test to make sure that that was going to work. So every single cable that I build, I run 5,000 volts DC through the pins to check for micro bridging. A lot of people will check continuity, and then they'll, use their multimeter to see, is the bridge to that. But multimeter puts out this tiny, tiny voltage. What I'm concerned about is arcing. So I want to know, obviously no one's running 5,000 volts, but I can do that. So I have a machine that does that. I don't hold on to it while you're testing it. I tried that once, it hurts. But this allows me to check every single one of these cables so that I know there's not any possibility of there's ever going to be a bridging. I'm never going to blow up anyone's amp. I'm never going to set anybody's house on fire. Okay, so that was the first thing. We figured that out. So then I felt, okay, now I feel comfortable doing this. So now what can we do that makes sense? What fits in with the what we've always done, right? Which is like, let's look at the numbers. Let's look what's important, what's not important. Obviously, gauge size is really important, right? You want a low resistance to ground. You want low resistance for your conductors because you got a lot of current going through there. You want impedance is an interesting thing with power cords, right? Because you're only running 60 hertz, right? So you want a super low impedance at 60 hertz, but you can actually have a really high impedance at higher frequencies. So this allows you to kind of do some funny stuff. Noise. We talk about noise with power cables a lot. I think people worry too much about noise going into power cables. There's a lot of stuff in a power supply that keeps that from getting in at all. So I don't worry about that too much, but coming out is another thing, right? The FCC does regulate that to some degree. So you'll see some devices that'll have a captive power cable. That means the FCC says this device puts out too much RF that's coming out of the cable. We need to manage that cable. So that's where you'll see shielded power cables. You'll see ferrites that are built into the cable. That's there because those things are tuned for that specific length of wire that's permanently attached to that device, that's keeping that high degree of RF from getting out into everything else and screwing everything up. But there's still some that kind of below that FCC threshold. So now we're like, how do we control this? Well, so I mentioned before, the whole impedance issue, right? So we want low impedance at 60 hertz, but we don't actually really care once we get into those higher frequencies what that impedance actually ends up being. So you can do things that you would never do with a signal cable, like for instance, EPDM insulation, that is going to absorb and prevent a lot of high frequencies from passing. Right, so it's almost like the opposite of what you're going to do in signal cables, right? You want to like, because you don't need to worry about capacitance with power cables. There's a huge, open up any of these devices. There's a big capacitor bank in there. It's like you're never going to get any higher than that. So it's like, don't worry about that. Inductance is important, but that's where your low frequencies is, right? So you're looking at your inductance to some degree to get that 60 hertz to pass. And then you then can start doing things where you're, like I said, you're preventing high frequencies, particularly RF, which is really, a bigger issue, but some of the other, ranges that, might get into your signal cables. So that's something that we looked at in here. We want to make sure that we got cables that are going to have a very low impedance at 60 hertz and a higher impedance as frequencies go up. And that's really the two main things that we focused on. A lot of other stuff that I saw that gets talked about in power cables was it was kind of flowery, right? And I don't know how to design for that. All I can do is make something that I know is, checks all those boxes that we just talked about, and then put it out into the world and then hear back and see how things are going. And it's been pretty good so far. So like I said, it's a new product for us, and I'm really excited to hear more about what people have to say, what improvements they hear, because that's always the most satisfying part for me in launching a new product.